What is the meaning of contiguous memory allocation? Contiguous memory allocation means physically the memory that is allocated for different elements must be in continuous. Means if this is your RAM, suppose I'm drawing it in 1D form. So these are the different elements. These are the different elements, okay, in your RAM. Now, it the meaning of continuous means if first element is stored in this position, second element must be in this position, third element must be in this position. It is not like that first, second, third, fourth in this position, not like that. It must be physically continuous. That is the meaning of contiguous. Okay, now see what happened in our RAM. Suppose this is our RAM and these are the different segments of our RAM. Okay, so our RAM memory is divided into different parts, which is called segments. Now suppose uh, suppose I am doing some word processing, and that is done in this particular segment. Okay, then suppose I am already opening some sort of say Excel sheet, so that is done in this position. Okay, now there was another work that I am doing, so we know that we can do multitasking, so there are different things that we are doing in our RAM memory. So this is our RAM memory, we are doing this. Suppose I have closed this part. It means now this is a free memory. This part is free because I have already closed the Excel sheet which I am working in this particular memory. Correct? Okay, now suppose there is another free space in this position, this particular position. So see, the free spaces are in these two particular positions. Suppose this free space having a size, this free space having a size 20 bytes, this free space having a size 10 bytes. Suppose, let us assume. Now I have allocated one integer memory array of 15 elements. Clear? Now how many memory is required for this 15 elements? Because since the size of integer is 2 bytes, so 15 into 2, it means we require 30 bytes of memory. And remember, this 30 bytes must be in contiguous form. Now see, here in our RAM there is 30 free memory. This, consider that these are already occupied by some work that is done in our RAM. So the total free memory here is 20 plus 10, that is 30. But it is not in contiguous form. There is a space in between which is already occupied by some other job. Clear? It means I have 30 free memory, this one and this one, but it is not contiguous. It means this array cannot be allocated in this particular memory space. So this is one disadvantage of contiguous memory allocation. How we can solve this? How we can overcome this problem of contiguous memory allocation? If somehow I am able to jump from there to there using something, it may be anything, using something, if I, after the ending of this memory, if I somehow jump to this memory and again continue, then we can easily access this 30 bytes. But for array, since we require contiguous, this is not contiguous, but the required memory space is there, 30 bytes is there, but the 30 bytes is not in contiguous form. It must be in contiguous like this, one after another. It is not like that 3 element there, then we will jump and move into another free space. This is not happening in case of array. So this becomes another disadvantage of array. So first disadvantage, static memory allocation, which is creating some shortage or wastage of memory. So we require runtime. So solution for static memory allocation is runtime memory allocation. Okay. This one, continuous memory allocation, means physically must be continuous. Physically it must be continuous. So this is again creating some disadvantage. So how to solve this? The solution is allocate scattered memory allocation. So scattered memory allocation. If the memories are scattered, one free space here, another free space here, another free space here, then somehow if I able to connect them and able to make them continuous, not contiguous, if I am somehow make them continuous, then we can say that it is allocating scattered memories or accessing scattered memory. So this is another solution for this particular disadvantage. Okay. Now the another interesting thing about array we have seen, in case of array, if we want to insert any particular element, suppose this is my array, if I want to insert any element, new element in this position, then we know we have to perform a shifting like this. We have to perform a shifting like this, and this shifting is very much time consuming. If I want to insert at the front, then shifting is order of n time complexity. I have to run a shifting operation. Similarly, if I want to delete this element from front, we have to perform a shifting like this. We have to perform a shifting like this, in this way. Again, the shifting will take order of n time complexity. It means it is a time consuming method. So these are the disadvantages of array, and to solve these disadvantages we will move to a new kind of data structure. So the solution of these problems is one kind of data structure, which is number one, dynamic. That means memory will be allocated at runtime. Number two, can access scattered memories. Can access scattered memories. Okay. Then number three, this insertion and deletion problem will be solved. So we required such a data structure which will be dynamic, which will access scattered memories, and able to solve the problem of this insertion and deletion. And the data structure which is able to solve these problems is called linked list. It's called linked list. The meaning, what is the meaning of linked list? I've already shown you there are some scattered free memories. These are the scattered free memories. This black portion, these are the scattered free memories. And now I am using some link. I am using some link like this. I am using some link to make them a list. I am using some link to make them a single list. That's why the data structure is called linked list. It is, the linked list obviously is dynamic. It can access scattered memories. It will easily solve the problem of insertion and deletion. Try to understand how it will solve the problem of insertion and deletion. Suppose this is one free memory. This is another free memory. This is another free memory. Okay, I want to add one free memory in between these two. So here the free memories are linked using some addresses. If I want to add one free memory, suppose this is, I want to add in between these two, then what I will do, I will link this from there and then link this from there. So only changing two link I am able to add, or if I want to delete this one, what I will do, I will link this from there to there. So only changing particular link, I can easily insert and I can easily delete a particular memory, or which we can say particular data. So this is the advantage of linked list. So now we are moving to discuss about what is linked list, what are the properties. So we have already seen how linked list is evolved. It is evolved from the disadvantages of array to solve the disadvantages of array. So now first we will try to understand what is the picture of a linked list. Okay. So the picture of a linked list like this. So these are the memory spaces. These are the memory spaces which I have to connect or link to make a single list. That's why it is called linked. The list elements are linked together. That's why it is called linked list. Okay. So it will be linked like this. So in each and every part of this linked list, which are called node. These are called node. This is one node, this is another node, like this. Okay. So each and every node of a linked list will be having two different parts. See, this is one part, I'm coloring it with blue, and this is another part, I'm coloring it with orange. So each and every node of linked list having two parts. This blue part is called data or info part, sorry, info part, information, and this the next part which will actually use to access or link to the next node is called the link or address bar. Okay. So each and every node, so if I draw it in a bigger scale, so this is the picture of a node, the node having two parts. One part is called data and another part is called link or address. Okay. So this is the picture of a node with two parts. So how it will be connected? This will point to this will point to this will point to this, like this. Now what is the meaning of this point? So this point is coming from the term pointer in C language. What is pointer? Pointer, you can say, is a kind of reference, or you can say it is a kind of address. We have seen in our C language that pointer means a variable which can store the address another variable of another variable. This is called a pointer. It means if P is a pointer and a is a normal variable, so a is a normal variable. Suppose this a having value 5 and the address of this is alpha, then what is p having? P having alpha. That's why p is pointing to a. If any variable having the address of another variable, here p is having the address of another variable a, that's why p is pointing to a. That's why p is called a pointer. P is called a pointer variable. So how to declare a pointer? The data type, suppose the data type is t, then star p is the declaration of the pointer. Suppose it will store the address of a variable type t of, so this is the variable a, so I have to write it p equal to ampersand a. P is having the address of a. See, the address of a is alpha, which is now stored into p. That's why p is pointing to a. So this is the meaning of pointer. So here, similarly, here also, this one pointing to this means this one having the address of this. So now the picture, I hope the picture is now clear. So suppose this is one memory location, this is another memory location, this is another memory location. Let us assume the address of this memory location is 100, starting address, this one 200, this one 300. Then you can easily say that this second part of the node having address of the next part, it means this one having 200. That's why this is pointing to this. How one variable will point to another variable? If that variable having the address of the next variable. So that's why similarly here, if this is pointing to this, then obviously this one having the address of next node. If this one having no, if this is the last node, then this one having zero address, which is also called null address. Okay, and we should start from a particular value. So that's why there is one pointer variable which is having the starting address, that is 100. That's why this is pointing to this, and this starting pointer is called start or head pointer. Remember, this is one pointer, this is not a node, but this is a node. Now this node having different values, this node having different values, but suppose this one having first element is 11, second element is 30, third element is 50. So these are integer nodes. So you can say that this is a node having two parts. The first part is an integer data part, correct? And the next part, what is the type of the next part? Obviously, the next part is a pointer. What is the type of the next part? The type of the next part is depends on the type of the node, because this will ultimately point to the node. So type of the next part or link part is depends on the type of the node. Okay, now how to define the type of the node? See, this node having two parts, this is not a single representation. In C language, whenever we will go to represent one thing using more than, so if we want to represent one entity, suppose I want to represent one entity complex number. If I want to represent complex number, we know that this is not a single entity. This is having two parts. One is the real part, another is the imaginary part. Similarly, if I want to say point in a coordinate system, we know that if it is a 2D point, then it should have two different values, x value, y value. If it is a 3D point, then it should have x, y, and z. So this representation of entity like complex number, point in a coordinate geometry, they are not single entity, they are combination of more than one entity. Similarly, node in a linked list is not a single entity, it is a combination of two things. One is the data part, another is the link part. And whenever we want to represent this type of things, we require our user defined data type. We need our user defined data type. Our inbuilt data types are int, float, char. These are our inbuilt data types. But to represent one entity which is a combination of more than one entity, we require user defined data type, and the user defined data type in C language are represented using structure and union. And if you remember, the here we definitely go for structure, because union is used when there is a limitation in the memory, or when we are using something where there is a default type of thing, or there are multiple options. Among these multiple options, finally we will choose one single one, then we will go for union. Here we require both data part and the address or link part, so we have to define it using a structure. So the type of this link is depends on type of the node, and the type of the node must be a structured type or user defined type. Okay, I hope up to this clear. Now we are going to define a structure for a particular node. So how to define a structure for a particular node? So struct is the keyword to represent any structure. then we are giving some tag name. Suppose we are giving the name node, so struct node. Then what are the members in this struct node? We have already defined there are two members. One is a data, another is a link. Now see, data can be integer or float, whatever, or character, or itself another structure. So here for our simplicity we are considering that our data is integer. So I am defining one member dt as our integer data members to store the to represent the data part, where I will store some values. And the next part is a pointer. We have already seen why next part is a pointer, because it is pointing to the next. So that's why the next part obviously is a pointer. How to define the pointer? We know we can define the pointer using pointer symbol and the variable name. Now the question is, what is the type of the pointer? Now remember, the type of the pointer I have already told, it should be the type same as the node type. Now what is the type of the node? The type of the node is struct node. So the pointer type also here is struct node. I hope it is clear. Why the type of the pointer variable is struct node? Because it will point to the next node. What is the type of the node? The type of the node is this one, struct node. So that's why pointer type is also struct node. Clear? And remember, this type of structure is called self-referential structure. Why this is called self-referential structure? Because the structure is pointing to itself. Where it is pointing? It is pointing to a type which is itself. That's why it is called self-referential structure. So this is, if I define this, then it will be like this. If I define this, so this is my new structure. If I define a variable for this structure, say node, say a, then this is our a, this is our a, and it is divided into two parts. One is the integer part, data dt, another is the link part. Okay, now can you, anyone please tell me what is the size of this data part and what is the size of this link part, so that I can measure the size of this variable a. What is the size of this variable? Please anyone tell me what is the size of this particular variable a, which is a structure type. Please tell me the size of this a, which is a structure type. What is the size? What is the size of this data part? What is the size of this data part, and what is the size of data is
4 bytes.
If you consider integer as 4 bytes, then it is 4 bytes. Okay,
Yes, sir.
then what is the size of link part?
Sir, 4 bytes.
Why?
10.
So pointer would be 4 bytes because it is a 64-bit operating system. So
Okay, everyone agree with the size of this link part? It is 4 bytes. Everyone agree?
8 bits.
Huh?
8
Sorry,
bytes.
8 bytes. So total size of A is 8 bytes. Yes, correct. 8 bytes. And I am asking, do you agree that the pointer size is 4 bytes? Everyone agree? Okay. So everyone agree that the pointer size would be here 4 bytes. Yes, this is true. Now, but there is one but. There is, remember, there is two types of pointer. One is called near pointer and another is called far pointer. So normally near pointer having the size of integer, whatever the size of integer, that will be allocated as a size of near pointer. But the size of far pointer is, remember, it is long int. Okay, so if you know what is near pointer and what is far pointer, then you can easily understood that why the size of near pointer is 4 bytes, size of integer. Now suppose instead of integer, if this is character, if this is data part is character, then what is the size of this A? Please, anyone? If it is character, then what is the size of this A?
4.
Two.
What is the, so for integer data, the size of this A is 8 bytes. Now, if the data is character, then what?
4 bytes, sir.
5 bytes. 5 bytes.
5 bytes.
Good, 5 bytes. 5 bytes. Why? Because character is 1 byte, this one is 1 byte, and this link part is having address. Address is always unsigned integer. Remember, address value is always unsigned integer. That's why it is always taking the size of integer. If your integer size is 2 bytes, then this address will be 2 bytes. If your integer is 4 bytes, then this address will be 2 bytes. But it depends on near and far pointer. Okay, so now it is clear that how to declare the size of this. So now if I declare a variable struct node A, then the picture will be like this. Means I have a node whose name is A. This node having two parts. One part is dt, another part is lk. dt is for holding the data and lk is for holding the address of the next node. Okay. Now the next thing is, I want to create, suppose I want to create a picture like this. Two node, one static pointer. So I want a picture like this. I want a picture like this. This one having say value is say 10. This one having say 15. And this is end. Okay. So suppose I want a linked list like this. So remember, this one is called start pointer or head pointer. Okay. H or ST, whatever you want. Suppose the addresses are this one having address alpha, base address, starting address. This one having beta. Then according to this picture, this should have alpha, this should have beta. This one null pointer. Generally, null pointer or zero value is represented in pictorial representation of linked list. It is represented like a earthing. So this is the picture I want to create. Okay. So what I will do, first I will create a variable A. So A, suppose A is this one. The next thing, I will create another variable, say B for this one. So, sorry, for this one. So these are the two different nodes I have created. Now the next thing, I have to allocate some element in A and then in B. So what is the name of this element? The name of this element is dt. Now, if you remember in your C class that how to access structure member using pointer variables. If you remember, then if you remember, you will see that there is a very interesting operator which is called arrow operator, which is a combination of minus and greater than. This operator is called arrow operator. And what is the use of this arrow operator? The use of this arrow operator is to access structure members using structure type pointer. Here, if this is a structure type pointer and this is accessing this members, then we have to use this arrow operator, or you can say a pointer operator. Okay. So how to access this member? So the picture is like this. This one dt, this one lk, and what is the name of this? A. So I have one head pointer like this. So what I will do, first I will write it like this: H equal to ampersand A. Am I clear? Because this is A, this is A. What is the address of A? Alpha. Where I should put it? I should put it into H. So I have written it like this: H equal to ampersand A. So done. So now after this statement, my picture is like this: H, this is A. If the address is say 100, H is having 100, it means H is now pointing to this. So this structure pointer is now pointing to this structure. Correct? There are two different members, DT, LK. How to access these members? We know we can use this arrow operator. So H arrow DT is the name of this member. This one H arrow DT. What is the name of this one? This is H arrow LK. Suppose there is another pointer T which is pointing to this, then we can also say this is T arrow DT and this is T arrow LK. It means whenever a pointer pointing to a structure, the members will be called like this: T arrow DT, T arrow LK. So here H is pointing, so H arrow DT, I am allocating 10 here, and then H arrow LK is pointing to here. So this is H arrow DT, this is H arrow LK. So H arrow LK having what? The address of the next. So I will write it like this: H arrow LK equal to ampersand B. Then this will point to this. Okay. Now I have to access this one. What is the name of this one? If the name of this one is H arrow LK, this is the pointer. So what is the name of this one? If this one is pointing to this, what is the name of this one? Obviously this should be H arrow LK arrow DT. And what is the name of this one? H arrow LK arrow LK. I hope it is clear. If a pointer P is pointing to this, then the name of this one is P arrow DT. Now here, this memory is pointed by H arrow LK. So the name of the pointer is H arrow LK. Then obviously this should be H arrow LK arrow DT, and this should be H arrow LK arrow LK. Okay. By writing this two, I can access the next two memory spaces. H arrow LK arrow DT equal to 15. See, 15 is stored here. And then this one is null. So I will write it H arrow LK equal to null. Then this is null. So if I write this 5 simple statements, then the picture that I want will be created. Now I have to define this H. The H obviously should be a structure type and pointer. So that's all. If I want to create a picture like this, a linked list of 2 nodes, then I have to write this 5 statements. Okay. Now, since this memory allocation is dynamic, I have told you at the start of this linked list that linked list is always dynamic. So if I want to make it dynamic, I have no idea how many nodes I have to create. So I have to create this node structure in a fly. In a fly means on the runtime. On the runtime, I have to take from the user and then I have to create a node. I have to ask the user, do you want to create a node? If user say yes, then I will go for creation of a node. So then it becomes runtime. Okay. Now see, by accessing this memory location, see, I have no idea where this A belongs in the memory. Suppose this is RAM. Suppose A belongs to this location and B belongs to this location. This is already occupied. Now see, here I have allocated A here, B here, then I have linked this to scattered memory. These two are scattered memory. They are not contiguous memory. They are scattered memory. Now I have linked this to scattered memory writing this statement. Whenever I am writing this statement, this link will be created. It means now From there we can easily jump into there. Similarly, if I have another scattered memory and I am able to store the address of this scattered memory alpha in this position, then I am able to jump from there to there. So this is the advantage of linked list. It can easily access or link. It can easily access or link the scattered memories. Similarly, if you want to add a new memory here, just what you have to do, you have to point this address link will be point here and this address will point to there. Then it will be added in between. So insertion and deletion will be easily done in case of this linked list. Okay, we will discuss the different operation creation. So similarly, link like array, linked list is another data structure. Remember, using array and linked list, we are able to implement or represent any other data structure. These two are the basic building block of any data structure. For array, we say it is physically linear. For array, we say it is physically linear. For linked list, we say it is logically linear. I hope why it is logically linear you are able to understand, because the memory is not contiguous, it is scattered. But ultimately we are moving continuously. That's why it is called logically linear. Okay. Using this two data structure, we can implement any other data structure, whether it is stack or queue or tree, non-linear data structure or graph, whatever we can able to represent or implement using these two. That's why these two are the basic building block of any data structure. Okay, so the linked list is evolved from the disadvantages of array. We have seen what are the disadvantages: static memory allocation, contiguous memory allocation, and insertion deletion in case of array. These are creating some problem. So that's why we are moving to linked list. And this is the basic idea of linked list. In the next class, we will discuss about different operation of linked list. Same like array, we can use, we can insert, we can delete, we can search, we can sort, but the sorting techniques in case of linked list is totally different. I will show you. So in the next class we will discuss about these different operations. Okay, so with this I am ending today's class.